Hey guys, in today's video, we are going to be talking about performing calculations with fractions. So that'll be adding, subtracting, multiplying, and dividing with fractions. So let's start off by having a look at adding and subtracting fractions. When we add and subtract fractions, we need to make sure that our denominators are the same, right? So as we can see, for these two fractions, we do not have the same denominators. So there are two ways in which we can make the denominators the same. One way would be by multiplying each fraction by the denominator of the other fraction. So to see how we would do this, as our denominator for the second fraction is 3, we would multiply the top number by 3, and we would do the same for the bottom number. Remember, since we're multiplying both the top and the bottom by the same number, we are not changing the value of the fraction, because we are essentially multiplying by 1. Because we multiply the top by 3 and the bottom by 3, 3 over 3 is simply 1. Next, we can do the same for the second fraction. So we multiply the entire fraction by that bottom number. So we multiply the top by 4, and we do the same for the bottom. So this will then change to 3 times 3 is 9, 4 times 3 is 12. Right, there we plus. Now the second fraction was 4 times 1, which is 4, over 3 times 4 gives us 12. So you can now see that our denominators for each of the fractions are exactly the same. Because they are now the same, we can add the numerators. So we add 9 to 4, and we get 13 over 12. Right, we would do the same thing when we subtract, but instead of us having a plus sign, it would be a minus sign. So if our original question was rather not 3 over 4 plus 1 over 3, rather it was minus 1 over 3, this would be a minus, and we'd say 4, or rather 9 minus 4, which would give us 5 over 12. Another way to do this would be to firstly multiply our denominators, so we get 12. Next, we have a look at the diagonals, and we say 4 times 1 is 4, because we've got a plus sign, we plus. And next we have a look at 3 times 3, which is 9. Right, so we first had a look at 4 times 4, 4 times 1, and that gave us 4. Then we had a look at 3 times 3, and that gave us 9. So we add those two numbers up, put them over 12, and that once again gives us 13 over 12. So it doesn't matter which procedure you use, you will still get the same answer. Let's get into some examples. Question 1 asks us to add 1 over 4 to 1 over 2. Now remember what I said earlier, we need to make sure that our denominators are the same. For this example, we can see that it would be relatively easy to have both our denominators be 4. So to do that, we would need to multiply this first fraction by 1, and we multiply the second fraction by 2. Because as we can see, 2 times 2 will give us 4. So now we carry on. 1 times 1 gives us 1. 1 times 4 gives us 4. Plus 2 times 1 is 2. 2 times 2 is 4. Now we have that our denominators are the same, so we can add the numerators. When we add two fractions, the denominator always stays the same. We add the numerators, and we get 3 over 4. And that is our final answer for question 1. For question 2, we are asked to add a third to a sixth. Now, once again, we can see that it would be relatively easy to make both our denominators 6. To do that, we simply need to times the first fraction by 2 over 2, and we would multiply the second fraction by 1 over 1. So we can carry on now. 2 times 1 gives us 2. This is now over 2 times 3, which is 6. We plus, as the question told us to plus, 1 times 1 is 1, over 6 times 1, which is 6. So both our denominators are the same, which means that we can now add the numerators. So, as our denominators are the same and we're adding fractions, we keep the denominators. Now we add the numerators. 2 plus 1 is 3. We are not done there yet. Next, we can see that the number 3 goes into 3 as well as into 6. So, if we divide that by 3 and we divide that by 3, 3 divided by 3 is 1, 6 divided by 3 is 2. And that is our final answer for question 2. Always, always, always have a look if you are able to simplify the fraction. Right, so while 3 over 6 is correct, it is more correct to simplify your answer and write it as 1 over 2. Question 3 asks us to add a fifth to a quarter. Now we're going to need to make use of the methods discussed earlier in the video. So we said that we can multiply the fractions by the other fraction's denominator. So that means we will multiply the first fraction by 4 over 4, and we'll multiply the second fraction by 5 over 5. Next, we can actually perform the multiplication. So 1 times 4 is 4. 4 times 5 is 20. Plus, now 1 times 5 is 5, and 4 times 5 is once again 20. As you can see, our denominators are now the same. So when we add, we keep the denominators. And we can now add our numerators. So 4 plus 5 is 9. And there is no number which goes into both 9 and 20. So this is our final answer for question number 3. Question 4 asks us to minus 4 over 5 by 2 over 4. So once again, we are going to multiply each of the fractions by the other fraction's denominator. So that means that we will multiply the first fraction by 4 over 4. And we'll multiply the second fraction by 5 over 5. Now we perform the multiplication. So 4 times 4 gives us 16. 5 times 4 gives us 20. Minus 5 times 2 gives us 10. And 4 times 5 once again gives us 20. Our denominators are the same, so we can now subtract the numerators. When we do that, our denominators stay the same, so that's 20, and we can now go 16 minus 10 gives us 6. Lastly, we need to have a look if there are any numbers which go into both 6 and 20. As we all know, 2 goes into both 6 and 20, so we can divide the 6 by 2 and we divide the 20 by 2. 6 divided by 2 is 3, and 20 divided by 2 is 10. This answer cannot be simplified any further, as there's no number which goes into both 3 and 10. So that is our final answer for question number 4. Question 5 asks us to subtract 2 over 3 by 1 over 4. For this example, I'm going to use the second method of adding and subtracting that I mentioned at the beginning of the video. To do this, we first need to multiply 3 by 4, so that will be 12. Secondly, we need to look at the diagonals and multiply. So, firstly, we've got 2 times 4, which is 8. And we're going to minus, because the question tells us to minus. Then we will say 3 times 1 gives us 3. So we simplify that. 8 minus 3 gives us 5, and that was over 12. As there is no number which goes into both 5 and 12, this is in its simplest form and is our final answer for question number 5. Question 6 asks us to multiply 4 over 5 by 3 over 8. Now it's important to remember that when we are multiplying or dividing fractions, it does not matter if our denominators are not the same. To multiply two fractions by each other, all we do is we multiply the numerator and we multiply the denominator, and that is how we arrive at our final answer. So 4 times 3 gives us 12, 5 times 8 gives us 40, and now we need to find a number which can go into both 12 and 40, and that number is 4. So we can divide both the numerator and the denominator by 4. 12 divided by 4 gives us 3, and 40 divided by 4 gives us 10. Now there is no number which goes into both 3 and 10, therefore this is our final answer for question number 6. For question 7, we need to multiply 8 over 9 by 1 1/4. Now obviously we see that this is going to cause a few problems. So to prevent that from causing any problems, we need to turn that fraction into an improper fraction. So let's do that. We're going to keep the 8 over 9 times. Now to convert the mixed number into an improper fraction, we multiply the 1 by the 4 and we add the 1. So 1 times 4 gives us 4, plus 1 gives us 5. So that becomes 5 over 4. And now it is simple fraction multiplication. So 8 times 5 gives us 40. And 9 times 4 gives us 36. Now we can see that the number 4 goes into both 40 and 36. So we divide both the numerator and the denominator by 4. 40 divided by 4 is 10, and 36 divided by 4 is 9. Now as there are no numbers which go into both 10 and 9, this is our final answer for question number 7. For question 8, we're once again asked to multiply mixed numbers. Now, we will once again do the same thing we did in the previous example, and that was turning the mixed numbers into improper fractions. So, we say 5 times 3 is 15, plus 1 gives us 16. So for the first fraction, we will have 16 over 3, and for the second one, 2 times 4 is 8, plus 1 is 9. So that becomes 9 over 4. Next is simple fraction multiplication. So 9 times 16 gives us 144, and 3 times 4 gives us 12. Now we can see that 12 goes into both 144 as well as 12, so we can divide both the numerator and the denominator by 12. So 144 divided by 12 gives us 12, and 12 divided by 12 gives us 1. So our final answer for question number 8 is 12. Question number 9 asks us to divide 1 over 6 by 8 over 11. To divide fractions, all we need to do is to flip or rotate the second fraction and then multiply. To show you what I mean, we'll say 1 over 6. Now instead of divide, we say times, and I said we flip the second fraction. So 11, which was the denominator, becomes the numerator, and 8, which was the numerator, becomes the denominator. And now it just becomes simple fraction multiplication. 1 times 11 is 11, and 6 times 8 is 48. And since there is no number which can go into both 11 and 48, this is our final answer for question number 9. So as you can see, dividing fractions is just as easy as multiplying fractions, as long as you remember to flip the second denominator, and from there it is just multiplication. Lastly, question 10 asks us to divide 11 over 2 by 1 over 2. Once again, when we divide fractions, we need to flip the second fraction and multiply. So this becomes 11 over 2 times 2 over 1. 2 times 11 gives us 22, and 2 times 1 gives us 2. Lastly, we need to find a number which goes into both 2 and 22. And that number is obviously 2. So if we divide 22 by 2, that gives us 11. And if we divide 2 by 2, that gives us 1. 11 over 1 is 11. So our final answer for question number 10 is 11.